One of my favorite things about doing what we do is that we get to deal with lots of weird problems that most people don't consider. The problem I wanted to show you today is, well, we don't really think about wire as a component. It's just a little conductor, right? Wire is wire. Well, we're working on a project that's going to send instruments down deep into wells where we might have half a kilometer, or more wire spooled out between the surface and the instrument. Well, then wire is not a component. Even if you're just using tens of feet of wire, 100 feet, you have to think about it some. But when we have this much wire, it becomes something we really have to worry about. So this spool of wire, for example, if I were to power it up and then disconnect the power, this has created a big coil, and that's going to cause a massive induction that could damage my components. So if I really want to test what 100 feet of this wire is going to do, I need to string it all out, and that takes up a lot of space. It takes up a whole lot of space when we're talking about a kilometer of wire. So we put together some little test jigs, and these test jigs are just laser cut acrylic, and they're for 22 gauge wire because that's what we're going to have going down our borehole. And I used these metal film resistors from Amazon, and they're close enough to the resistance of the wire that it will work for this. I actually overbought the resistance just a little bit. And you know, I've bought these Amazon resistors several times now. I was nervous about them, and I'm not going to say I would use them in something that is going to get deployed in Antarctica. But for lab tests or for quick little circuit tests, these have been great. I don't have to pay shipping like I do with DigiKey. I don't have to wait as long as I have to on DigiKey. They're here the next day and no problems. I've tested quite a few of these on a meter and they were dead on. So overall, I'm pretty happy with them. And for something like test jigs, no big deal. These test jigs, I built two because we've got one for the power going down, one for the ground return path. They've got two values. So I've got a value here of 10 ohms, and that's 200 meters of wire. And then the rest of the values are 27 ohms, and that's 500 meters of wire. So I've got a kilometer, 2 kilometers, 2.5 kilometers, plus 200 meters. So that gives me 2.7 kilometers total that I can simulate with each one of these. Just some banana jacks, didn't cost much, but they're all put together now. Jonah actually did the laser work and soldered everything on. So let's hook it up and see how close this is just for fun. We're going to take our meter, I've just got a little X-Tech 330 here, and measure, see how close we are. Let me flip this over, maybe we can get a little bit clearer view for you without the focus going out. So yeah, auto ranging takes a second, especially in these really low ranges. Yeah, 10.4, okay. Let's see, what about the 27 ohm? Yep, 27.0, dead on. But now let's simulate a kilometer of wire. So that's two 500 meter resistors or two 27 ohm resistors. And again, we're auto ranging for a little bit. And yeah, we're at about 54, just under 54 ohms, which is what we would expect. So as you can see, that's a lot of resistance for a kilometer of wire. It's going to limit how much power we can put downhole to the instrument. That's why we have to be very efficient with our power design, even though these instruments are generally being powered by some surface source that's semi-infinite. But we do have to worry about things like the resistance of the wire, and I thought you might like to just see these test jigs. Another one of the fun problems that we have to deal with that a lot of folks don't.